Section 3. Text tricks, definitions, and heuristics. In this section, we're going to look at the particular challenges of text data in comparison to other kinds of data. Once we look at that and discuss ways to mitigate those challenges, we'll look in more detail at how we can split text into parts and turn those parts into numbers that can be understood by a computer and fed into some kind of downstream algorithm. Finally, we will briefly revisit our SMS spam classifier in light of these techniques. Understanding text as noisy data. In this video, we're going to take a look at how noise can arise in language and methods to clean the text to mitigate the presence of this noise. And the purpose of these next few videos is to try and impart some of the knowledge that comes with experience from dealing with text data. Okay, so the first thing to consider is ambiguity of meaning. If we consider these two sentences, he was taken outside and shot by the soldier, and she was given a flu shot as a precaution, we have the same word, shot, having two different meanings in these two different contexts. And remember our comparison of computer language and natural language. In the case of human language, we have words that can have different meanings depending on context. And this is a challenge for us to encode and explain to a computer. Negation. The first sentence, it was a great event and everyone enjoyed it. The state of the car engine was not great after the race. Imagine we were trying to determine whether these sentences had a positive or negative sentiment. If we look for the word great, we would conclude that both sentences had a positive sentiment. But of course, the second sentence has not before great, which reverses the meaning. So we need to find ways to capture negations. Sarcasm. It's brilliant how they failed to do anything they said they would. I am amazed it wasn't better. So brilliant and amazed have some kind of positive connotations, but actually they're being used ironically or sarcastically to impart a negative sentiment. Misspellings. Spellings are particularly common in social media. I don't know how they did it. So we need to find a way to make some sense, some meaning of misspellings. And also come across different word forms. I do, we did, they were doing. All of these are different forms due to different tenses of the verb to do. So in some sense, we want to be able to recognize all of these different forms and map them back to a single meaning when they're from the same base word form. So the conclusion immediately is text data is always dirty. So you will always come across these challenges whenever you're dealing with text data. And unfortunately, it's impossible to completely clean and account for all of these difficulties. There are certain techniques to improve the situation, but you'll always come across some unwanted noise or dirty words present in our text data. But we do have some solutions in hand. Keyword filtering can remove ambiguous words out of context. So when we're forming our corpus, we return to our example of shot being used to describe a vaccination and shot being used to describe a gun. We could have some kind of filtering rule that says filter out all of the documents that match shot but do not match flu. And that way we can get rid of the documents that are talking about vaccination shot and keep the ones we want. Common misspellings can be found in databases of misspellings, so we can learn to map dunno to don't know. Stemmers can collapse different word forms to a base word form. Thinking about negation, not good and not great, instead of using features that are single words, so just good and great, we can use so-called bigrams, which capture two words together and treat them as if those two words were one word. And that allows us to capture a bit more nuance in our sentences. The disadvantage here is that we now have more features. If we count single words and bigrams together, then we have a bigger feature vector and more complexity, and we generally need more data to be able to learn effectively from those bigrams. Sarcasm remains a particularly difficult problem to deal with. There has been some work in the literature on how to detect sarcasm, but as of yet, there's no real good solution. It's always good practice to take your text and begin by stripping out punctuation, and also putting all of your text in a lowercase, so basically ignoring the information that comes with knowing that a word should be capitalized because it's at the beginning of the sentence. That's not significant for basic meaning of the sentence. So this first sentence, I have been thinking I should learn NLP, becomes I have been thinking I should learn NLP. Another concept that's very important is the idea of StopWords. StopWords are an important principle in natural language processing. It's always true, it's a universal law in pretty much all text from all languages, that you have some words that appear very, very frequently, while others appear not so frequently. And we can see this empirically. I've taken data from Shakespeare's works from Project Gutenberg, and I've counted the occurrence of all of the words in that work. This bar graph shows the top 10 most commonly occurring words, and they are the, and, I, to, of, my, in, that, you. As you might expect, those are articles, bridging words, prepositions, and so on. And these are present in pretty much every single sentence, and they don't really add very much information. So it's common practice to remove those stop words. So for example, I have been thinking I should learn NLP now becomes have been thinking should learn NLP. And there are already compiled lists of stop words for different languages, so you don't need to compile them all yourself. And if you're dealing with a particular kind of text data, a corpus from somewhere in particular, you might add words to that set of stop words. For example, one time I was working with constitutional documents, so I added the word constitution and article and law to the list of stop words because they were present in every single document and were not adding any information. Let's recap briefly the example notebook that we saw in the previous section, where we built a very simple spam SMS classifier. You might ask where these tips and tricks and pre-processing of the text data come in here. And actually, it's all being done in Count Vectorizer. Count Vectorizer does a lot of hard work for us and chooses default options for all of these methods by itself. Count Vectorizer takes our text, splits it into words, removes punctuation, converts it to lowercase, and all of these other options, and we can specify them further still. We can say, I want to consider not just single words, but also bigrams or trigrams or fourgrams or as many grams as we would like. All of that is customizable and goes on in Count Vectorizer and gets applied to training data xtrain and returns back the result in xtrain counts.